Today what we're going to do is, this is going to be a longer video, so I actually apologize for you in advance, but there's a lot of topics to do with factoring, so bear with it. But our topic today is factoring. And we're going to deal with four basic types of factoring, but we have a game plan for how to approach a factoring problem. If you ever see a problem that says factor, you can always assume that it says factor completely. Even if they don't say the completely, they mean completely. So whenever we factor, we do certain things in a certain order. So the first thing we always do is, one, see if there's a GCF to factor out. And remember, a GCF is greatest common factor. Okay, so that's the first thing we're always going to do. We always want to deal with things that are smaller rather than bigger. And if we don't look for the GCF to start with, we always have to double check it at the end, and then it gets more confusing. So I always like to start by looking for the GCF. Now, here's the problem. A lot of your homework problems won't have the GCF along with the different things. So you have to remember it's there, even though you're going to get in the habit, in the practice of not having to face it that frequently. So first of all, we think it's our GCF. So we're going to do some examples about looking at this. But this is our cover sheet of our game plan for factoring. Step 2 is count the terms. Now remember, terms are any groups of net letters and or numbers that are separated by a plus or a minus sign. Basically what factoring does is going from a polynomial, which is many terms, down to a single term dealt with parentheses. Because once I can get everything into multiplication, it's down to one term, and then I can work with it later on. Because we're going to be doing factoring till the end of the course. So next week is going to be even more factoring, followed by more factoring and more factoring. So, and the final has lots of factoring. So you're going to be pros at factoring, but you need to practice. And it's definitely one of those topics that lots of practice is needed. And I don't expect perfection to start with, as always, but you have to practice, because otherwise you're not going to get it. And just looking at the stuff, it looks great. Until you get the pencil or the pen to the paper, it's a lot more difficult to do that. So count the terms. And then when we count the terms, we're going to have three different things. You could have two terms, which is hopefully be a difference in squares. If it's not a difference in squares, if it doesn't work with that, we're going to get those directions. But if it doesn't work with the difference in squares, then after you got the GCF, that might be all you can do. So it might be completely factored by that. The next type is three terms, and that's a lot of work. It is trinomials. And your book will go through a whole bunch of different trinomials and a lot of special cases. I do it by unfoiling, is the way I consider it, and it works for every single case. It just might be more writing and stuff, but it works. So it's less trying to figure out what specific case do I have. I have something that always works. And I think of this as unfoiled. That's not an S, that's an N. So fixing that. Writing is not a strong point. So, like I said, the book, lots of different examples. There's a lot of special cases for factoring with trinomials, and there's a lot of shortcuts that you can get really proficient at doing it. But learning it, first off, I do it as opposite of foiling, which remember we did before, where it's distributing to more things to more parentheses. And then the last type is, I'm going to tell you, I'll do it right again. And this is four terms. And this is by grouping. Okay. And basically when I unfold something, I'm going to try to get it to be a four-term problem, because they're actually a lot easier. It's just a lot of GCF work to do. So this is the the basics of factoring of where we're going to start. So we always check to see if there's a GCF, and then we always count the terms, and then depending on how many terms we have is what type of factoring we're going to be doing. Now, in the folder, I also have put a PowerPoint that does essentially this, but you don't get my lovely voice to listen to. Wording might be slightly different, and it'll probably be different examples, but it's yet another case of if you click through it, you can make what I call factoring cards to go with your directions so that you can go one thing at a time for all your factoring problems, which are going to be forever. Okay, we've done some stuff with GCF before, so let's give you some formal notes on greatest common factors. So GCF. Okay. Can take back from everything. So imagine you made cookies for people at work. And you made 2 batches because you have a group of people that are allergic to nuts, so you had to make sure that there were cookies that were nut-free completely and safe for those people with the allergies. And now say you passed out the cookies and you accidentally started with the allergy-free ones, so the nut-free ones, and you gave them to the people that didn't have allergies. You have to ask for them all back so that you can give them to the proper people. So this is kind of what a GCF is. It's the opposite of distributing, and it's what can I take out of everything? So if we get a problem like this, book up. All right. So that gives you 12x to the third minus 60 x squared y plus 36 x y cubed. Okay, so that's the problem. Directions, because they're oh so helpful with life, and they tell you factors. You always okay, so steps. I always like steps. You don't have to follow my steps, but sometimes they can help if you really get stuck when you're starting out things. So I always look at letters first. Same with when I solve equations, I like to look at the letters before I look at numbers. So look at the letters. Step 1. Okay, so first of all, I'm going to look at the letters and see if there is or are any letters, that all the terms have. So I need to see, look at all the terms. Currently I have 3 terms. Remember, terms are separated by the plus or minus, so the first term is the 12x to the third. Second term is the negative 60x squared y, and the third term is positive 36xy cubed. Now I'm looking at it, and I'm looking at only the letters, and I see x's and y's. And I see that they all have an x, different exponents, but they all have x's. So going with that first step is, if there's a letter that all the terms have, write the common letter. Write the letter down. Okay, so in this case they all have x's, so I'm going to do that. And then I look at the y. And there's a bunch of y's up here. But I noticed that only the second and the third term have the y, so the first term has no y, so I can't use the y because I wouldn't be able to take it back from that first term. Write the letter and use hi. Okay, just being here. If you have questions, I can help you with that. I just basically started with some factoring stuff. I'll finish up the GCF and then we'll see if you have some questions to go with this. And then we'll work on getting some more stuff in. Okay, Rihanna? You don't have sound yet, but or maybe you do. Okay. Anyway, we'll finish this. Okay. Write the letter and use the smallest exponent you see for it. And if I'm looking at them, I have an x to the third, which means 3x's, x squared, 2x's. And this one just has a plain old x, which if I need to see the exponent, it's a 1. So that's my smallest. So just a plain old x. I didn't have an exponent to add to it. I can put a 1 there if I really need it. Okay, then the next thing that we have, that's my letters. I can't do any y. So 2. Okay, so the next thing is look at the coefficients, see if there's a number that divides nicely, I don't like decimals, into each of the coefficients. So this is one of those places where I could be a little organized if I need to, because if I just start randomly guessing numbers, I never get the number I need. So I try to be as organized as possible. It'll help you later on as well. So my coefficients are 12, negative 16, I don't really care about the negative right now, and 36. So I start by writing all the factors, and I do this very systematically because, like I say, if I do it randomly, the number I need is the one I miss. So I start with 1. 12 divided by 1 is 12, or 1 times 12 is 12. And then I say, okay, after 1 is 2. Does 2 go into 12? Yes. So 2 times 6 is 12, and I keep going. 3. 3 goes into 12 4 times. And if I would keep counting, I'd be down to 4. 4 is next. But 4 is already written in the other column, so I'm done. I've got every single factor that goes nicely into 12. Doing the same thing with 60, it's 1 and 60. I always do the 1 because if you forget it, you need it. 6 is even, so 2 times 30. 3 goes into 60. 3 is 20. 4 goes into 60 15 times. 5 goes into 60 12 times. 6 goes into 60 10 times. 7 doesn't go. 8 doesn't go. 9 doesn't go. And I'm back to 10, so that's all of them. Bigger numbers are not so far. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. I don't have a whole classroom of people who stop me when I do things wrong. 6 and 6. And since they repeated, I know I'm done right there. All right, so now I'm looking for the biggest number, and I'm going to put we want the biggest. Okay, so we want the biggest number that's in all of the list. So if I'm looking, let's keep it blue. 12, 12, 12. It can be in either column, and if there wasn't one, it would. If nothing else matches, you always have one that matches. And when we do later factors, you do have to take a GCS, so sometimes the 1 is the one that we have to deal with. But in this case, it's 12. Okay. So then we get to step 3. And I start running out of room. 3. Divide. Divide the GCS. Meaning, I'm going to physically, this is my GCS. So I'm going to write 12x underneath each one. Remember, fractions just division. Okay. Make. Okay, so we're going to start with parentheses. So that GCF is outside of parentheses, is what I'm taking out. And now I'm physically going to divide each of the terms by the GCF. So 12 divided by 12, they cancel out. If everything else, 1 on the bottom, I have 2 more on the top, so it's x squared. And then a negative divided by a positive is negative. 12 into 60, I can actually look at the 60 list. 12 matches 5. There are 2 x's, so there's 1 more on top, and don't forget your y. And then a positive divided by a positive is plus. 36 divided by 12 is 3. The x's in this case are cancel out. I just have y to difference. So that is GCS. Lots and lots of fun. So 3 steps. Next step. Final answer is right here. Okay, so GCS, very important to start with. Okay, so then let's go back to the very first step. Okay, so we'll see. Okay, so GCS. So that's the first thing we do in the first example that we did was just a GCS problem. Sometimes they'll be nice enough to tell you what type of factoring you're going to do. Most of the time, no. So, new pages. So, going back, that's GCS. Then we're going to look at an actual, okay, let me know if you have questions. But otherwise, I'm just going to get through all the notes and extra stuff that you need for factoring so that you'll be good to go. All right, so we need more factoring. Because it's so much fun. All right, example. Let's give you something other. Big numbers. Not so fun, but big numbers. Okay, so first of all, so this is going to be 1. Remember the GCS. That so I have more workspace. Okay, so looking at GCS, my coefficients, now there isn't a letter for both of them, so I don't have a letter to pull up for GCS. So if I'm looking at just the numbers, 72 and minus 800, totally nice. Looking at my factors, 1 and 72, even, so 2 and 36, 3 and 24. I assume for 4 and 18, 5 doesn't go in there, 6 and 12, 7 doesn't, and 8 and 9. Yay. I think I have it right. Hopefully it is. 800, 1 and 800, 2 and 400, 3 doesn't go in there, 4 and 200, 5. This is insane. What was I thinking? 9 doesn't go in there, but 10 does. 10 and 80. 11 doesn't go in there. 12 doesn't. 13, 14, 15, 16, 50. Okay, and I keep going into the things, but I'm looking at this, and I do know that 8 is going to be my biggest, just because I picked this thinking of it to start with. So this one still keeps going, but my division head is not working too well. So I'm going to take an 8 out. Start divide by 8. So that leaves me with 9x to the 4th minus 1. Okay. Now, the other thing that you have to remember, so to make sure you have the following. All exponents even. Okay. So I need to know what my perfect squares are. So I'm looking once I calculate GCF, I'm really just looking at the parentheses stuff. The A is going to be part of my answer, but I'll deal with that as part of my answer. So I'm looking for a negative sign. It might be in the middle or it might be in the front, but I just need one of them to be negative. I need all the exponents to be even, which I have, and then I need all the numbers to be perfect squares. So I need to know what perfect squares are. So you can have yourself a list of these or just recognize them, but some of them people forget. So the way we get perfect squares is we just do can't have 2 pencils at once. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, and you can keep going. It's just 3 numbers. So it's just actually figuring out what is 1 times itself. 2 squared is 4. 9. Remember, it's the number that's that base number, so the 3 would be squared. So 3 times itself, not times 2. And now bigger perfect squares. Okay, so the perfect square. So I'm looking at my coefficient. 9, perfect square, because it's one of my green numbers. 100, perfect square, because it's one of my green numbers. Okay, then the next one, this sounds so silly, but most of the stuff I do not so typical for math type of thing. So now I have to think, and I have to think of something I have an experience with. So Easter basket for twin kids that are about 4. So if you think about if you're making Easter baskets for a set of twins that are 4 years old, and you think about what you're putting into them, you have to have the exact same thing in both of the Easter baskets, or you have a war on your hands usually. At least in my family, that's the way it works. So that's what we're going to think about. Think of it Easter baskets. So make Easter baskets. And I'm going to do okay. And your Easter baskets are just 2 sets of parentheses. One's a plus, one's a minus. Okay, so right underneath here, my Easter basket, a plus and a minus. Okay, now I have to divvy up the stuff from the black parentheses into those 2 separate parentheses. Now, the opposite of squaring something is called square root. It means what times itself. So it would be our red numbers in our list of perfect squares. It's what times itself gave us that perfect square. So, giving myself a little bit more room. So step 4. And then the back of that. Then the other thing that you have to do with this, I have 4 X's and I have to split them up. So each basket gets 2 of them. Okay? And then I look at the 100. What makes 100 is 10 times 10. So if I want to multiply together, so that would be 10 and 10. Okay, I also have to not forget that I have my GCF here, which is the 8. All right, so this is actually a process. Okay, so basically you have to double check your parentheses and make sure there's still not a difference in squares. So if I look at the first one, I have a plus sign. Automatically doesn't meet my criteria from step 2, so I don't have a negative. Looking at my negative one, I have to double check it. Are all my exponents even? Yes. Are my numbers perfect squares? No, they're not the green numbers from the list. So this is my answer. All right, those aren't too painful. The next one's become more painful. Okay. No questions? We're doing okay? Just checking. All right. Then we'll go on to, remember my very first page? I said count the terms, so we did the 2 terms, we did the GCF. I'm going to skip the 3 terms because they're ugly, but 4 terms actually help us with the 3 terms. So we're going to do the the 4 terms next and then come back to the 3 terms. Okay. Going back. 4 terms. Okay. And like everything else, you need an example. Because we like examples. We will give you an ugly example. Because we can. Yay, that's not so pretty. There's too many letters. But in any case, they're going to tell you to give you that and tell you to factor it. And you might not like it. So your steps, remember to check for GCF. Okay, but I look at the letters first. I have m squared, m, no m. So I can't use the m. I look at, the last 2 are the only ones for the c's, so I can't do a GCF, so life is good. I still have to factor. So, 4 terms. We've already counted the terms. In this case, I don't care on the order of things. They can be in whichever order they want. It should still work. Your middle steps might look different than somebody else's. So step 2. Group. Okay, so you're going to group the terms, and you're going to give yourself a little bit of room to work with, but it's term 1. Give yourself a little bit of room. And I would say pluses, even though there might be minuses in my problem. It's always, I think, of positive when I'm writing notes. So, and then I worry about term 3 and term 4. Okay, so in my problem here, really like my board. Okay, anyways, it's a simple thing. Okay, so these are my first 2. These are my second 2, and I'm kind of still dealing with that minus sign in brain that I have to. So, 1 term at a time. If you need post-it notes, are a great thing to cover up. Unfortunately, with the smartboard, I can't cover up over the computer, so you're just going to have to assume that you can see my arm covering it up. Okay, so remember, we did GCF at the beginning, and that's looking for what do they have in common. And I'm really only looking at, is there anything that goes into coefficients? No, only 1. And since I already have something written down, I don't need to write that one, but you can. Okay, so if you're factoring it out, then you write the GCF underneath. Okay, positive divided by positive is positive. I had 2 on top, 2 m's on top, 1 on bottom. I'm going to be left with 1 on bottom. A positive divided by a positive is positive. And 5m divided by m, the m's cancel out. That's not too bad. It's just more fat GCF. So grouping is going to be a lot of GCF. And some of them are going to look kind of ugly. But we can deal with that. I'll do it. See what colors. Right. Actually, no, I'm going to do it in red. I apologize. I like red better for this red. Okay, this info is a little silly, but when you're dealing with negatives, which really are not my friends and totally need me, I need to deal with them, and I need to make sure that I'm paying attention to them. So my 4th step is always bring down the sign, whether it's a plus or minus, of the 3rd term. In this case, the minus, so it's coming down with the minus. That's going to be part of your GCF from the 2nd group. You don't have a choice. It has to be. Okay, so then step 5. Factor, not 5. And this is that you have to use the sign. Have to write the 1. You have to have a GCF for step 5. And it can be just the number 1. But in this case, I'm looking at it, they both of the factors, looking at the letters, they both have a T. They don't have any numbers in common, so I could put the 1 that I'm dividing out of all the terms as a negative T. Negative T, that's not a 6, that's a T. And it looks awful. Probably would be worse. Negative T divided by negative T. Now, this negative, I just copied it down. I still have it in the problem. So a negative divided by negative is a positive. So when I'm looking at the MT over the T, so the negative MT over the negative T, it's a negative divided by a negative. So that becomes a positive. The T's, so the negatives cross out, the T's cross out, and you just have an M. Then I'm looking at the negative 5T and the negative T. A negative divided by a negative is positive. The T's are going to cancel out, and you have a 5. Okay? So when we look at it, small pieces at a time, it's not so bad. I didn't say it was fun, it's just not so bad. Okay. Now, we still have more stuff. Your next step is, I need more stuff. If they don't match at this point, check to see if the numbers match and it's just a sign thing because you could have forgotten a negative sign. If they are completely different, your problem might not be factorable. But double check that you didn't make any mistakes in your work and that you are looking for the GCF so you find the biggest thing that you can take out of things. So in most cases, they will match. And if they don't, you made a mistake. And mistakes happen. And I'm good with mistakes. Just if it's a sign thing, it's that minus sign in the middle. So my parentheses match. What I'm doing is I've now, if I looked at the original problem, I had four terms. And now, right now, even though it still looks like a mess and it doesn't look any neater than it was, and it's not, it's just mathematically it helps you a little bit more, I have 2 terms. Okay, so this whole group of things is 1 term, and this whole group of things is my 2nd term. So I've gotten it down to 2 terms. And in math, to be able to cancel stuff out, we need to get it down to 1 term, which is you can have a bazillion parentheses. As long as there's no plus or minus between those parentheses, we'll be happy because if everything is multiplication, it's a lot easier. Okay, so I'm looking at those terms. Their parentheses match. So really what I'm doing is taking a GCF of the parentheses out. But I write it a little weird. Okay, so write the parentheses at 1. Okay, so my parentheses were M plus 5. Okay. Now, if you want to think of that as a GCF, you might have it in front. If you want to think of, oh, it's in the back of each one of those terms, it can stay in the back. Order doesn't matter because remember, multiplication goes in any order. But so I wrote that once. It's in common. Okay, and then the next thing is making more space. That's no big problem. 7 is your last step. Well, no, 8 is your last step. Okay, so if I'm looking at this, I have an M and a minus T. So that's going to go M minus T. And step 8, make sure okay, mainly we're getting down to 2. In most cases, you won't be able to factor anymore. But if you forgot to factor GCF, you might have to look at it at the last step. So just make sure you can't do any more with the parentheses, and you're good. Okay, let me check and see if this makes sense. Okay, just check. I like to pester. I'm not used to having people in here. I love having people in my class. I think my dean's actually going to come down to listen to this. And then he's watching my class tonight, so he's going to get factoring like a pro. I'll be able to have him as sub. Great. All right. The last type of factoring that we have to do is the 3 terms. So I just need to make sure that the 4 term makes sense. Yes! Awesome. All right, because the 3 terms is a lot more work, and it comes back to getting it to 4 terms, because we can do 4 terms. They're not too bad. They're a little tedious, but they're straightforward. So when we have the 3 terms, they're not so pretty. They're a lot of work. And like I said, the book has its own little shortcuts for them, which you can use. I'm perfectly great with them. However, I do it one way. All right. So let's find an ugly one. I like ugly ones. So this is 3 terms. And I call this anti-foiling or unfoiling. I can't write today. That's long. Not that I can write most days, but today seems to be worse than this. Okay, so the goal is basically we're going to start with 3 terms, and we're going to make it to 4 terms, and then we're going to deal with that. Let's see. Ugliness. Factor. Example. Okay. Minus 28. T's and C's. Really don't like them, but I was having them look out. All right, so first step, same as everything. See if there's a GPS. So I shouldn't have to repeat myself, but I do, because this is actually a very important first step. So even though it's on the first step of our notes, we're going to keep reminding yourselves to do it. Okay, and in this case, there isn't anything. I look at the letters. 2 of them have B's, 2 of them have C's, but all 3 of them don't have the same letters. And there is no number that goes into 49, 4, and 28. Awesome. Okay, so step 2 is actually really important. It's kind of critical that you find an ordering system. So step 2, put your terms in order. Okay, now, when you have more than 1 letter, which isn't going to happen that often, but I'd like to give you the worst case scenario in examples so that when you see something, if it was a worst case scenario, you've at least got something that you can reference with. So if you have things with more than 1 letter, you can start with one of the letters, and you want the exponents to either count downwards or count upwards. So you're going to look 1 letter at a time. I would pick the B's first, just because B comes first in the alphabet. It doesn't matter which letter you pick with. But if I pick my B's, I want to start with my highest exponent. So I'm looking here is my highest exponent of B. That's kind of creative. That's a B2. And then I have a plain old B, and then I have something else that has no B. So if I put them in order with my B's, counting downwards, I would have 49 B squared. And then I have minus 28. Remember the negative signs attached to the coefficient. B to the 4th B And then I have a term that didn't have any b's at all, plus 4c to the 8th. So that means the b's in order counting down, but now let's double check with the c's. If I start